Hello everybody, my name is Costa Canels. I'm the sales manager at Dedert Corporation. I'm here with you today at the Dedert test facilities in Homewood, Illinois. We're just located about 20 minutes south of Chicago. Dedert is a multinational company. We specialize in drying and evaporation systems worldwide. So the test facility here that we have here in Homewood, Illinois is a critical part of our success to develop products and systems for our customers. Let me take you through a walk through the system. For starters, let me take you to the lab. So the lab is where we do our initial base case analysis of the product. So when a customer has an application, he wants to concentrate or evaporate a product, we bring it to the lab. And this is where our pipeline manager, Greg, would come in, get the material, and conduct some preliminary trials. And the function of these trials really is to assess what the product looks like, how it behaves, so we can determine what evaporator technology would be best suited for it, as well as what drying technology. So that's what the basic focus, and that's really step one. So we take great pride in to help customers identify early on what the best system would be for their specific product. So let me walk you through here. So when we're doing an evaporator application, we really need to understand the physical properties of the material. So we run kind of two major parameters which really affect the evaporator design. One is boiling point elevation, and we use this reboiler here to determine this property. We also use a rheometer here, which is right here, and that rheometer will tell us viscosities. And with this information from the viscosity and the boiling point elevations, we compile a property file that we put into our master program, and then that would help us generate the sizing and determination of the evaporator design that's best suited for the customer's application. And for drying applications, exclusively we measure bulk densities, we do oven, we take oven measurements to determine how easy the product is to dry. If it retains a lot of moisture, which is diffusion limited drying, we call it, or it readily releases the moisture, which is in the constant rate drying zone. So let's go over to the pilot plant. Let me bring you over to the first piece of equipment we'll talk about is the evaporator system. So what you can see here is the Dedert evaporator. It's a pilot evaporator. It's designed for approximately 150 pounds per hour evaporation. The system, for those who don't understand or don't know what evaporator does, what evaporator true function is to concentrate a liquid. So if a customer has a product that has a high concentration of water and very little solids, we will put it through an evaporator to concentrate it up. So we can concentrate very many different products from stillages all the way up to sweeteners and other products. What the evaporator here we have for really two major technologies. We have a falling film technology as well as a forced recirculation. Again, based on the pilot plant testing we do, we can assess what technology is best suited for it. So we typically would also produce some samples for customers who need a certain amount of product required for their lab analysis, or even give some samples to their customers. Over here on the left-hand side is the ring dryer technology. What a ring dryer does is it usually takes a paste, a cake, a sludge, or something that comes off of the watering device, such as a press or a centrifuge, and we dry the material into a powder-like form. So the ring dryer here we're seeing has about an evaporative capacity, depending on temperatures we run, about 150 pounds per hour evaporative capacity, which is a good size, especially now with customers these days. More and more of our customers are developing new products. They're trying to provide value-added product or generate value-added products. So this mechanism, this tool, which we have as a pilot plant, really helps us solidify the customer's trust in our equipment by demonstrating how we can dry the products. The advantage of the ring drying technology is really it really dries material in the order of seconds. So we can get product into the dryer, and we'll have a more demonstrative video coming up shortly on the ring dryer technology. We'll give you a tour of it. But essentially, we would take the cake and put in the dryer, and within seconds, 5 seconds, the material is dry, in and out, to preserve thermal properties, minimize thermal degradation of the product. And the key feature, for those who don't know, is the manifold, which is shown up here. The manifold is one of the main features here in the ring dryer technology, which determines how to selectively recycle the semi-dry product and discharge the dry product out of the system. So we do very well. We have a tremendous installation based on ring dryers, and we will continue to develop new applications with our customers. So this leads me to the latest addition to the Dedert pilot plant. It's our spray dryer. So the spray dryer here is a 3-meter spray dryer, and it's designed for 150 kilograms per hour evaporation capacity. So this spray dryer we put in was installed in 2017, so it's about 3-4 years old. And it's a state-of-the-art system. The spray dryer, unlike a ring dryer which takes a cake or a paste, the spray dryer's function is to take a liquid, and we atomize it, make discrete droplet particles, and we produce a fine powder, or for that matter, agglomerated products. This pilot plant here, which I'll explain in more detail, is very multifunctional. So what I'm showing you right here is a high-pressure nozzle, a high-pressure pump. When we use nozzles to generate these fine discrete particles, we use a high-pressure pump to force this liquid through and spray it into the chamber. Alternatively, we could use a rotating disc, which is called a rotating atomizer, to generate these discrete particles. So we have many different ways to generate these particles. And the 3-meter chamber on top, which we're panning up to see, can also be multi-configurational. Some customers want a fine powder. So when it's a fine powder, we would just create a single-stage dryer, which we would just spray the material in and discharge it out. However, more and more customers are requiring some functionality in their dried product, and they want it maybe easily dispersible. At that point, we make it, or non-dusty. For that matter, we would reconfigure the system, and it's presently shown as a 2-stage configuration presently, and that's when we want to create an agglomerated product. So whether the customer wants a fine powder, agglomerated, we can do it high-pressure nozzle, rotary atomizer. We have the full functionality of this pilot plant to do it. Again, many of our customers require tons of product for market analysis, and that's what this pilot plant is designed to do. In essence, the real growth in our marketplace is with new products. And with the Dedert pilot plant, I'm sure if we come here and you give us a chance to show you our capabilities, we'll far and exceed your expectations. I hope you found this video and this demonstration to be informative. If you have any questions, feel free to contact Dedert at dedert.com. And thank you very much for your attention. Well, let's now continue with the demonstration part of the video. Today we're going to look at an overview of the ring drying technology. For those who are not familiar with the ring technology, it is a pneumatic type of dryer where we get the product in and out of the dryer in the mere matter of seconds. The product gets circulated around the system so that we minimize any thermal degradation of the product at all times. The pilot plant you're seeing right now is designed for an evaporative capacity of 150 pounds per hour. So, which is a good size system when we conduct pilot plant trials, as well as we can conduct campaigns for customers when they require a couple of tons of material for marketing studies or feed analysis. So the system here we have is controlled by a PLC. So with the PLC, we can get to record all the parameters, operating conditions when we run the system. And with that, with those parameters, we can successfully design the system to a full-scale production unit. Let's come around the other side. Here's an overview of the ring technology. There's a variety of components which consists of a mixing section, a disperser, ring dryer, and a manifold. And I'll go through those sections in detail just to get an overall view of the system. So what the ring dryer does, unlike any other technology like a spray dryer, it takes wet cakes, pastes, wet granules, and dries those materials into a fine powder. So when the material is often at times very sticky or wet, the material is introduced into a mixer. And I'll show you what the mixer looks like. The mixer is a twin shaft paddle mixer. And you can see there are two shafts that rotate around the system. And the purpose of the mixer is to take the wet cake and distribute it, the moisture over a larger surface area. So if we have a really wet and sticky material, the mixer will distribute the moisture into a more surface area to make the material more friable. When we say friable, what we want to do is we take the material in our hand, we squeeze it, we tap it, and it crumbles. That's what we want to do. And when that happens, we introduce it into the drying section of the dryer. So the material will come in and enter a disintegrator. The function of the disintegrator is to break up any agglomerates any further. So if we have a big piece, we want to disperse that into finer particles so it gets pneumatically conveyed up and around the drying system. Once it makes the loop, it enters what we call a classifier, where this is specific to the ring dryer. The classifier works by centrifugal force. The heavier particles, or the bigger particles that enter the system, follow the exterior surface of the ducting and gets reintroduced back into the drying system. Where the finer material, which is less prone to being taken away by centrifugal force, gets circulated around the system and gets conveyed into the cyclone for product collection. On our drying system, we use a natural gas burner as a heat source for the drying. So let's wrap around here and I'll show you how the product looks. So the product out of this system typically is a fine powder. And what we're going to do here is show you the product discharge comes out of the cyclone and discharges into a barrel, which you can see fine material coming in. So the material that left the mixer and discharged into the cyclone was out in a couple of seconds, which is, again, a very important feature for thermally sensitive products. We also have a dust collector here. The dust collector's function really is a emission control device for our purposes, but also can serve as a secondary collection point. The other thing we can do on our pilot ring dryer, where we have a lot of customers that are looking for thermally energy efficient solutions, drying is one of the most expensive ways of removing water. So we can recirculate gases out of the system. So this is the fan that draws air through the system. We can recirculate up to about 65% of the air back into the dryer, which reduces the energy demand and helps with the overall profitability and reducing the OPEX of the dryer. So when customers are drying some thermally sensitive products, this could be a very good advantageous solution. So this was a quick overview of the system. Feel free to contact us if you have drying inquiries which require ring drying as a solution. Thank you very much, and I wish you all a pleasant day.